All right, welcome to the deep dive. Today we are putting a pretty specific piece of hardware under the microscope.
A very specific piece.
It's the WolfPack 4K30 HDMI Output Card. Now, it's just a $250 component, but the sources we have, these dense engineering notes, they really lay out an entire philosophy.
They do, yeah.
So our mission is to get past the price and the alphabet soup of acronyms and really understand what makes these big AV systems tick.
The kind you see in sports bars, casinos, that kind of thing.
Exactly. Okay, so let's just jump in. What is the foundational appeal here with this whole modular architecture?
Well, at its core, it's all about risk management. I mean, we're talking about massive matrix switchers.
Like 18 by 18, 36 by 36?
Huge systems, yeah. Think about a sports bar with 50 screens. If that system goes down, it's not just an inconvenience.
It's lost revenue, a lot of it.
Right, so that's where the modularity becomes, well, it's kind of like an insurance policy.
Oh, I see.
The key engineering decision here, the real aha moment,
Yeah.
is the use of these one-port slide-in cards. So if output, say, number 16 fails, you don't send the entire 36 by 36 chassis back for repair.
Which would take weeks.
For sure. Instead, you just slide out the faulty $250 card, pop in a spare, and you are back online. Instantly. It just minimizes that costly downtime.
That focus on stability, it seems to carry right into the specs. I mean, we see 4K UHD support, but the source specifically calls out 4K at 30 Hz. Why not? I mean, why not push for 60 Hz if it's a 4K card?
And see, that's the core engineering trade-off they're making. They are prioritizing stability, absolute stability, over frame rate.
Right.
By limiting it to 30 Hz, they keep the bandwidth well within that 10.2 Gbps limit. That means they can support 48-bit deep color, and the signal holds up over long runs.
Right, which is crucial in those high-stakes environments you mentioned. They're designing for uptime, not for, gaming.
Exactly.
Now, let's talk about the headaches this card is designed to eliminate, because every integrator dreads ED and HDCP issues. How does it handle that whole digital handshake mess?
Yeah, that can be a nightmare. So EDI errors, that's when the display and the source just get their wires crossed.
And you get a black screen.
Or worse. This card just simplifies it. It has built-in EDID learning. You literally press a button on the card twice, and it copies the display's profile.
And that's it.
That's it. It just cuts out that whole failure loop.
I was also fascinated to see how they manage HDCP. It looks like they built in a lifeline for older gear.
Oh, they did. It has internal HDCP 1.4 management, and this lets you choose to open or close the HDCP on the output.
Which is a huge feature.
It's massive for pro integration. It means if you have one older, non-compliant display in an otherwise perfect system, you can still show the secured source. You don't lose the whole feed.
That solves so many problems. But this flexibility, it comes with a pretty hard line, right? The source material had a really strong warning about technical isolation.
It does, a very strict rule. You cannot combine these 4K30 HDMI cards with any of the older 1080p base cards.
Like SDI, VGA, or DVI.
None of them. Not in the same chassis. These 4K cards have to run in a pure 4K30 system.
That sounds like a big step backward for anyone running mixed systems, though. Doesn't that force a complete rip and replace?
It does, but it shows you what their non-negotiable mandate is. Mixing those cards introduces different clocking, legacy bandwidth. It can basically contaminate the whole signal chain.
So they're saying if you want zero instability, you have to maintain total signal consistency.
That's the deal.
Okay, we've covered the hardware integrity, but system control is just as vital for uptime. What are the options here?
Oh, they're expensive. I mean, beyond the standard WebGUI and the free mobile apps, they have compatibility with all the big players. Crestron, Control4, Elin.
The usual suspects for custom integration.
Right, but what's really interesting for pros is the RS-232 scripting.
You mean just skipping the bulky drivers from those companies entirely?
Precisely. For a custom team writing their own drivers, the commands are just remarkably simple. To switch input 8 to, say, outputs 1, 8, and 16, the command is just 8 by 1 and 8 and 16.
That's it.
That's it. The matrix just replies, OK, or ERR. It's so straightforward.
And I guess underpinning all of this design is a real focus on quality. They talk about a 6-step testing procedure, even a 24-hour aging period.
And that focus on minimizing downtime carries right through to their support. The warranty promises to ship a replacement unit within 24 hours if tech support verifies a failure.
So your system won't stay dark for long.
That's a guarantee.
So what does this all mean? I think our deep dive shows that this kind of pro hardware is really built around strategic trade-offs. You limit frame rate for stability, demand system consistency, all to maximize uptime.
Exactly. And my final thought for you to mull over is this. Given how simple and direct that RS-232 scripting is,
Yeah.
does the ease of writing your own drivers for hardware like this ultimately save more time and money for an installer than relying on those prepackaged, sometimes complex, and often costly drivers from the big control systems? It really forces integrators to rethink where the value is.